In sample problem number 3, the center is not at the origin. So this is the H and this one is the K. Therefore, the center is at 3. So just copy the numerical numbers but with opposite sign. So this becomes -2. So to plot the center, it is in quadrant 4. So we have positive x coordinate of the center, then negative coordinate for the y. So this is the center. Then the larger denominator, since the larger denominator is under the term with variable y squared, the major axis is parallel to the y-axis. So let's solve the value of semi-major axis by getting the square root of 25. So this becomes 5. Then for the semi-minor axis, get the square root of 16. So it is equal to 4. So to plot this one, so we'll start with the semi-major axis. So let's locate the vertices of major axis. So it is 5 units away from the center. So we are going to count 5 from the center. So 1, 2, 3, 4, 5. So this is located here for the first vertex of the major axis. So, while for the other vertex, so let's count 5 since it is 5 units away from the center. 1, 2, 3, 4, 5. So this is here. Therefore, the vertex 1 is at 3. Then for the y coordinates, so positive 3. Then for the vertex 2, 3. And for the y coordinates, coordinate of the vertex 2, so -7. -7. Then for the semi-major axis, so the vertex, so we will count 4 units away from the center. So 1, 2, 3, 4. So this is located here for the third vertex. So that is -1. So v sub 3 is -1, -2. Then for the last vertex of minor axis, 1, 2, 3, 4, it is located here at positive 6. Therefore, the vertex is V4, 6, -2. So let's connect all the vertices to form the ellipse. So that is the ellipse. Then for the coordinates of the foci, we can solve it by getting the square root of a squared minus b squared. So a squared is the larger denominator, 25, minus 16. So the square root of 25 minus 16 is 3. So to plot the foci, so it is 3 units away from the center. 1, 2, 3. So it is located here. Then for another focus, so 3 units away again from the center, it is located here. Therefore, the coordinates of the focus is 3, 1. Then the other focus, F prime, at 3, negative 5. So to summarize, so these are the vertices, the coordinates of the vertices for major axis. So we have B sub 1. So from the center is 3, negative 2 plus 5. That's why its coordinate is 3. Then positive 3. Then vertex 2, 3, negative 2 minus 5. So the next vertex is 3, negative 7. Then for the minor axis, V sub 3, this will be parallel to the x-axis. So from the center, so you will add the distance on the x-coordinate of the center. So this will become, okay, 3, this should be 7, not 6. 7. So 7, negative 2, then V sub 4, so minus 2, minus 4, so this becomes negative 1, negative 2. Then for the coordinates of the foci, so the first foci, so based from our computation, the distance from the center to one of the foci is 3. So you will add 3 to the y-coordinate of the center, since the center has negative 2 y-coordinate. You will add the distance 3. So this becomes 3, 1 for the first coordinate of the one of the foci, then F prime for the second focus. You will going to subtract 3 to the y coordinate of the center. So this become 3, -5. So that is correct. That is correct based from our graph. So we plot it correctly. So that's how we solve and plot an ellipse. Next example. Here, the center is 1 and -1. Again, just copy the numerical value but with opposite sign. So the x coordinate becomes positive, then the y coordinate for the center becomes negative since it has positive on the standard equation. Then to plot this one, so it is again at quadrant 4. So we have positive x coordinate, the negative y coordinate. So it is plotted here. Then for the major, since the larger denominator is under where the x squared variable, that means that the major axis is parallel to y-axis. So to solve the semi-major axis, get the square root of 9 becomes 3. Then for the minor axis, square root of 4 is equal to 2. Then again, to plot this one, so the vertices, coordinates of the vertices, or major axis, so we are going to add 3 to the since it is parallel to the x-axis, we are going to add the distance 3 to the x coordinate of the center since it is parallel to the x-axis. So this becomes v sub 1. So 1 plus 3. This becomes 4, -1 for the first vertex. Then second vertex, we're going to subtract 3. Then this becomes -2. Then for the minor axis, so it is parallel. So this time it is parallel to the y coordinates. So to get the coordinate of v sub 3, so you will going to add the distance 2 to the y coordinate of the center. So 1, -1 plus 2, so equals to 1, 1. Then for the fourth vertex, we're going to subtract -2 distance. So this becomes 1, -3. Okay, let's plot this one. V sub 1 is at is at 4, -1. This is 4, so it is located here. Then for v sub 2, it is at negative 2, 1, negative 1. So it plots here. Then for the v sub 3 at 1, 1. So at quadrant 1. Then for v sub 4, it is at quadrant 3. Located at at 1, negative 3. So let's check. So let's count the distance based from the plot. So the distance of the semi-major axis is 3. So from the center, so let's count 1, 2, 3. So that's correct. So 1, 2, 3. So that's also correct. Then for the distance of the semi-minor axis, it is 2 units away from the center. So 1, 2. Then it is also equal to 2 units, 1, 2. So that is correct. So let's connect all the vertices to form the ellipse. Then for the coordinates of the foci, so you will add the distance. So let's compute first the distance of the foci, or one of the focus from the center, to get the square root of a squared. So the larger denominator is 9 minus 4. So it will equate to square root of 5, or approximately equal to square root of 5 is 2.3 to 2.236 units. So to plot this one, so it is located here. So let's count from the center. It is 2.236 unit away. So it is located somewhere here. So for other focus, so let's count 1, 2. So therefore it is located somewhere here. Then for the coordinates of the foci, so F, we are going to add the square root of 5 to the x coordinate of the center, since it is parallel to the x-axis. So what is 1 plus square root of 5? So you get 3.236 negative 1. So just copy the y coordinate of the center. Then F prime for the second focus. So you are going to subtract square root of 5 to the x coordinate. We get negative 1.236 negative 1. This is F 3.236 negative 1, while the other one is at quadrant 3. F prime is negative 1.236 negative 1. Next. So in this sample problem, so we need to obtain the eccentricity distance between two directrices, then the distance between the center and directrix, then determine the distance between the center and focus, or the C. Then the last one is to find the distance between the two foci, or 2C. So notice, class, that the given equation is not at the standard form. So we need to convert it first before we proceed to finding those variables. So remember that the standard equation, if the center is at the origin, is given by x squared a squared plus y squared b squared equals 100. So let's divide both sides by 100. I mean, this one becomes 1. Let's move to another example. In solving this one, we need to convert it first in standard form. So by dividing both sides by 100, so 16 divided 100 is equivalent to 16 divided 100 is equivalent to 4 over 25. X squared plus 1 over 4 y squared equals to 1. But take note that we need to get the denominator for us to determine the major and minor axis. So by getting the reciprocal of this coefficient, so we get x squared over 25 over 4 plus y squared over 4 is equal to 1. In such a way, we can now determine the major axis and the minor axis. So based from this equation, the center is at the origin, since it is also equal to x squared over a squared plus y squared over b squared equals 1. So this is identical to this standard equation. So now we can determine the value of the semi-major axis. So get the square root of 25 over 4. So the square root of 25 over 4 is 2.5. Then for b, the square root of 4 is 2. Then to get the c, so the square root of 25 over 4 minus 4 is 25 over 4 minus 4 is 1.5. So let's solve the eccentricity. So based from the formula, E is equal to C over A. So C is equal to 1.5 over 2.5. Therefore, the eccentricity is equal to 0.6. Then for so this is the answer for number 1. Then for the next variable, we need to obtain the distance between two directrices. So for this one, we can get the directrix first. So based from the formula, D is equal to A over E. So A is 2.5 over 0.6. So to compute, is equal to 4.167 units. So just multiply the D by 2. So now we can get the answer for this item. So 2 times 4.167, we get 8.33 units. So this is for number 2, and this one is for number 3. So number 2, number 3. Then for the next variable, so distance between center, we already know the distance from the center. So we already solved it. C is equal to 1.5. Then distance between the two foci, so just multiply the C by 2. So 2C is equal to 2 times 1.5 is 3. So this is the answer. Next, find the standard form of the equation for the ellipse whose major axis has endpoints -2, -1, and 6, -1, whose minor axis has length of 6. So for us to be able to visualize it, let's plot it in our graph. So first endpoints is at quadrant 3. So -2, -1. Then for the second vertex, 6 and -1. So this is the vertices for the major axis based from the problem. Then to solve for the center of the to solve for the center of the ellipse, so how can we do that? So it has distance. So let's compute first the distance between the endpoints of the major axis along the x-axis. So 2a is equal to the distance of the x coordinates. So -2 minus 6. So the distance is 8. Then divide it by 2 for us to get the distance from the center. So the distance from the center is what? So distance from the center 8 over 2 is 4. So to count, so let's count 4 from one of the endpoints of the major axis. So let's say ito, galing dito. So 1, 2, 3, 4. So ito po banda, dito po banda yung center niya. Nakalocate sa 2 and negative 1. Then for the minor axis has length of 6. So total length niya is 6. Therefore, yung center natin has a vertex. The center has a coordinate of 2, negative 1. So to write the standard form, we use the x minus h squared since the center is not at the origin over a squared plus y minus k squared over b squared is equal to 1. So substituting the values of the coordinates of the center, so this one, so x minus 2 squared plus y plus 1. Since it is negative, so this becomes positive. So we will write the opposite sign, squared. Then for the distance of the semi-major axis, so it has 4. So this is the distance of the semi-major axis, 4. So 4 squared over the distance of the semi-major axis. Since the given is the length of the minor axis, this one, we need to get the half of the 6 to get the semi-minor axis. So equals to 3. So this becomes 3 squared equals 1. So to simplify, it becomes x minus 2 squared over 16 plus y plus 1 squared over 9 equals 1. So this is the answer. Then last problem, find the equation of an ellipse satisfying the given condition foci negative 2, 0 and 2, 0. Length of major axis is 10. So how can we solve this one? So based from the given, so it is located saan? So the center is at the origin. So to plot the foci, so negative 2, 0 and positive 2, 0. That means that it is 2 units away from the center. So therefore, the C, so the distance from the center to one of the foci is equal to 2. Then the length of the major axis is 10. Major axis is 10. So to determine the semi-major axis, so divide both sides by 2, so equals to 5. Then for the minor axis, so we have this relationship, c squared is equal to a squared minus b squared. This time you need to get the value of b. So transposing the b squared to the other side, then also the c squared to the other side. So this become b squared is equal to a squared minus c squared. Then to get the value of b, so get the square root of a squared. So 5 squared minus 2 squared is equal to square root of 5 squared minus 2 squared is square root of 21. So, or we can just simply get the b squared. So b squared, so a squared is 25 minus c squared, so it becomes 4. So b squared is equal to 21. So to write the equation or the standard equation, so this will x squared. Since foci is parallel to the x-axis, the major axis should be under the x squared variable. So a squared plus y squared minus over b squared equals 1. So x squared over a. So a squared is equal to 25 plus y squared. So we just computed the value of y squared, so equals to 21. So this is the final answer.